Hello, good evening, everyone. Yeah, Vinod. It's like it's been a long time. I saw that name Vinod, and it is Sanover. There is congratulations. Okay. Yeah, and well, last time yeah, sorry about that. I was getting a congratulation from my boss because my wife just had a baby boy, so this morning, and yeah, good evening. Yeah, thanks, George. Um, Yeah, Vinod, thanks. And so I'm a dad now. Good evening, Prabha. Well, it was a little bit complicated. I couldn't sleep last night, and I was on the phone constantly, and I had to do a cesarean session, and but she's fine, and then the baby is also fine, and I just saw the baby for the first time just about 5 minutes before this class. I had not seen the baby yet because she had to get her computer to the hospital to use the internet so I could see the baby. But thank God everything is fine, and a very big baby boy, and the baby is 4.1 kg. That's about 8 pounds something. Yeah, it's really good news. Anyway, that's not really part of our class, and but some good news is difficult to keep, right? That's you have to share it with people. Okay, we ended last time with an assignment. Um, it's still on the screen. Did anybody try their hand on it? What did you have? The question was, what would you make? Um, how much would you make if you play the game 1,500 times? And how much would you lose if you play the game 1,500 times? So we're looking at the probability of winning and losing if you play 1,500 times. So did anybody try to solve the problem? You can just post your respond your answer to it on the screen. But I'm going to take my video out so we can concentrate on this whiteboard. Okay, now this is the question. The question is about rolling a die. Now, a friend proposed a wager. That's the question. That's the whole thing. It's about a wager. I'm going to give you some money. Now, you will pay her $9. Maybe we can change it to rupees. We can change it to dirham. That's okay. So you will pay your friend $9. And then a fair die. We talked about a fair die. What does it mean? We said a fair die. Can somebody tell us what a fair die is again? Because progressively we're going to look at some aspect of business mathematics. Mr. Said talked about, did a little bit about on business mathematics. He looked at matrices and things like that. So I'm going to look at the probability and statistics part of it, which is very important, especially when you have to predict what's going to happen, the outcome of your decision, the outcome of the market, the outcome of lots of things you predict. And then the statistics, which is how you analyze data. So Probability is all about prediction. How things can happen. What are the likelihood of things happening or not happening? While statistics is all about data, how you handle data, how you analyze data. These are two areas everybody in the world of management or business should be able to understand. It should be at your fingertip. I'm going to look at that as we move along, but I'm going to look at it in context. For example, this is looking at it in context, because if we just take a topic like probability, it doesn't really make sense for so many people, because they're going to ask questions, but how is this useful? How is this going to help me as a manager? How is it going to help me as a business practitioner? So I'm going to put everything in context. So we're going to look at situations in context and then try to solve those different mathematical issues as well. So now, a fair die. Can somebody tell us again what a fair die is, and or what a fair coin is? A fair coin. A fair coin, a fair die. What does it mean? Vinod says a coin that has two sides. Yeah, that's true. All coins have two sides. That's true. But the fair, when it comes to it, George says that is with 6 sides. That's a die. Yeah, all die. We have dials with 4 sides. We have dials with 6 sides. But we're talking about a 6-sided die. And when we say fair, that is the word I was actually looking for. Fair. What does it mean, fair? If the coin is fair, it means that the probability of each of those sides coming up are equal. You get it? That is what it means. The probability of any of the sides showing up, they are equal. It's not like the coin is heavier on one side, which makes it more likely that the opposite side will be on the top, or it's not like the dial is heavier on one side, which gives more chances for the opposite side to be. Yeah, they are equally likely. That's correct, George. So when we say a fair coin or a fair die, we're saying that it's a die that has equal probability on all the different possibilities, all the different phases. Now, so and it's important that we make it very clear in the question. We said you have to pay her $9 to play the game, and the game is about rolling a fair die. Now, if the die comes up 2 or 3 or 3 or 4 or 5 or 6, then your friend will pay you $15. We looked at this part on Wednesday. Now, if the die comes up 1 or 2, then your friend is not going to pay you anything. And then you can play as many times as you wish. And then the question we looked at is, we looked at the different probability of winning and the probability of losing. And we said the probability of winning was 2/3, 2 on 3. And the probability of losing was 1/3, which means there is more probability of winning than losing. Now that you know there is more probability of winning than losing, the question I asked last time before we left is, what is the probability of how much would you make anyway if you play the game 1,500 times? So how much do you think you will make if you play the game 1,500 times? So if you play 1,500 times, how much do you think you would be able to make? And how much do you think you'll be able to lose? Did anybody try that? Let's look at the solution. Now, based on what you've already learned, this will happen. About probability, you know that the proportion of games in which you will win over the long run is approximately equal to the probability of winning a single game. Now we're going to multiply the probability over the long run. So thus, out of the 1,500 games you will play, you would expect to win approximately. Now this is the probability of winning. Now it's important that everybody takes note. That's good. I saw somebody put 1,000. This is the probability of winning if you play one time. Now if you play 1,500 times, it means you will multiply 1,500 times the probability of winning one game. And that is going to give you 1,000 times. And if you multiply this 1,000 times by the probability, how much are you supposed to get? Is $6. Do we remember how we got the $6? Can anybody remember how we got the $6? This 1,000 means the probability of winning. You have 1,000 times to win. If you play 1,500 times, you have a chance, you have 1,000 times chance of winning. Because the chance of winning one is 2/3. And if you play 1,500 times, and then you have a 1,000 times chances of winning. Now, so many people forgot, okay, yeah, the $6 came because they said if you want to play the game, you're supposed to pay $9 to your friend. And if you win, your friend is going to give you $15. So what is the net profit? You have to remove, first of all, what you gave your friend to play the game, and then the rest is what your net profit would be. So that was, as Prabha said, that is $15 minus 9, which gave us $6. So each time you win, you actually win $6. Now that we know the probability of winning, which means you will win, you are sure of winning 1,000 times if you play the game. Then, and each time you win, you have $6. So which it means it is 1,000 times 6. And then you are sure of losing. You will not win. If you play 1,500 times, you will not win 500 times. And each time you lose, you remember, your $9 will go away. Is it clear at this point? Each time you lose, your $9 will go away. Now, so to know how much you stand to gain if you play the game, you stand to the chance of it's $1,500. Now, if you do this mathematics, you can do it on your own. You see that the probability, what you stand to gain if you play 1,500 times, you stand the chance to win $1,500. So this game looks like a good idea. So it means, first of all, the probability of winning is high. And then you have the chance, the opportunity to play many times. So you multiply your chances of winning. You multiply how much you're going to win each time. Now, based on this logic, what is each play of the game worth? Now, you want to know if you play 1,500 times, how much is each game worth? What is the value of each game? Well, if 1,500 plays of the game are worth $1,500, then one play of the game should worth $1,500 divided by 1,500 times. So which means every time you play, whether you win or lose, that game is worth $1. So each time you play the game, the value of that play is $1. And you're going to see this because sometimes somebody's going to invite you for a meeting, you want to make a decision, you want to go through a product. You ask yourself, what do I gain? most of us, we ask this question: what is the profit, or what am I going to gain if I put in my time? So each time you play the game, that play is worth $1. Now, putting this into another way, or into a different perspective, you will make an average of $1 each time you play the game. Now, a little thought about the logic of these calculations show that you can directly determine the average payoff from one play of the game by multiplying each possible payoff from the game by the probability of that payoff. Now, so which means we can still take, we know the probability of winning is 2/3. And when you play and you have a 2/3 probability of winning, each time you win, you have $6. And we say we add probabilities, right? Because the sum of the probabilities of a particular event is equal to 1 or 100%. I'm going to explain that again in detail. Now, plus the probability of losing. If you lose, is 1/3 probability of losing times how much you're going to lose. So if you do this calculation, you still have $1, which means each time you play the game, whether you win or you lose, you make $1. It's a good game, isn't it? Okay. We can see that in the figure example 1.4, which is above. Is clear. So that is called the expected value. Let's look at what expected value is again more. The definition of expected value. The expected value for an uncertain alternative is calculated by multiplying each possible outcome of an uncertain alternative by its probability and summing the results up. You put the sum of the results up. Now, we're going to look at it better in another example. Now, the expected value decision criterion selects the alternative that has the best expected value. Now, if you want to make a decision, you choose a decision that has the best expected outcome. That is the relation with the probability. If I do this, which of the decision is going to give me the best outcome? Of course, you're not sure it's the best outcome, but you expect it to be the best outcome. So that is what you're definitely going in for. In situations involving profits, where more is better, of course, everybody wants more. The alternative with the highest expected value is best. Everybody wants the best. And in situation involving costs, where less is better, you know, we want to spend less and we want to earn more. The alternative with the lowest expected value is best. I don't know, do we understand this particular statement from here, from this point? Because this is very important for every business person. Not even only a business person, everybody. This portion is very important. Yeah, we all want to spend less and we all want to make more money. We want to put in less time and gain more. We want to spend less money and make more. So that is always the case. Let's take a look at another example. And then we'll go to a simple probability. And I'm going to explain what that means. Now, when it comes to product decision, again, remember the first product we talked about at the very beginning of this session. The expected value for the special instrument products decisions are designated by EV. If you go back to it, there is, I think it's down. Okay, this is it. So you can take a snapshot again with the expert idea. So you can take a snapshot. Now this is expected value. Can somebody tell us how we got this expected value? $400,000 here, $400,000 here, $310,000 here. Can somebody tell us how we got that? Just do the math. I'll go back to it. It's always good for everybody to try it. Just try a hand on it. Just a couple of minutes, it's okay. Everybody can do it. Just how we got 400 and how we got 310,000. Okay, Prabhu says net profit. I don't understand. I think we just did that a few minutes ago. We said you can add the probability. Let me just go back to it because this is something I really want everybody to take home. Now look at here. I said to know the expected value, you can multiply the probability of winning times how much you're going to win, and then you add it to the probability of losing times the value you're going to lose, and then you have the expected value. Now let's come back to this diagram. So how did we have $400? Can somebody do it for us? It's very, very easy. Just use the same. This one, Prabhu says sales revenue, $400,000 minus cost of production. Not really. I think this is the expected value of each of these decisions. That is whether you succeed or you fail. With the decision to develop the product, you know, it spreads into two. Let me see. Suvit says revenue times 0.5 minus costs. Again, something is missing. Okay, now let's go back to it. Let's look at it together. It's maybe the next one I can give you, but this one let's do it. Now, what is the probability of success if you take the temperature sensor? 0.5. Okay, so the probability of succeeding is 0.5. Oh, sorry, I don't have. I think I should get. I should type it, not because I don't have a. Let me put a box. Okay, so the probability of. Let me put it in a bracket. So the probability of succeeding for the temperature sensor is 0.5, and if we succeed, how much do we gain if we succeed? So we multiply by can somebody tell me? The net profit. We multiply by the net profit. This is the probability we are going to succeed. And if we succeed, how much are we going to make? We are going to make good $900,000. That is the net profit. So to get this probability, we have to come back here. We look at the sorry. Okay. So we multiply by 900,000. Okay. Now, if we multiply by 900,000, this is the probability of succeeding. But again, the total probability we have to add. So we have plus. What is the probability that we are going to fail? The probability that we're going to fail is 0.5. That's correct, 0.5. And if we fail, how much do we lose? So times, how much do we lose if we fail? We lose $100,000. So we're going to multiply by minus $100,000. So what is this equal to? So if you do this mathematics, it's equal to $400,000. Do you get it now? Hey, Joe says 500. It's 400. Try it again. Wow, I see lots of. Okay, Francis corrected it. Yeah, it's 400. If you do that, mathematics is 400. So you see, we have added the probability of succeeding plus the probability of failing, and then we had the expected value. So this is what we have here. And can we do this one down? The expected value for this section, if you choose to do a pressure sensor, you can do it. Let's see your working. You can type it and let's see how you got it. Okay. Yeah, Suvit says the probability of I think the way you arrange this mathematics is a little bit confusing. I think you should try to rearrange it. All the data is correct, but the way you arranged it is not going to give you the correct answer if you compute that on a calculator. The data is correct, but the mathematics has to be rearranged. Something is missing. Yeah, Vinod, that's good. The way you arranged it is good, but something is missing again. Something is still missing. Can you see that, Vinod? Francis, something is missing again, or something is more again. Now, when you do the expect, of course, this is the answer we want to get. We want to get how do we have $310,000 as the expected value? How did we get it? And I'm seeing the mathematics. I want to see the mathematics because that is going to give me some confidence that at least you know why you got the figures, and then you can also do it in where you work, whether it's at home or somewhere else or someplace else. I'm interested in seeing how you arrange the mathematics. I did mine up here. You want me to show you again? Mine was pretty simple. Well, it disappeared. Okay, it's back. Now, the probability of success is here, 0.5. This is the probability of success is 0.5. So this is it. And if you succeed, what do you make? If you succeed, you're going to have a net profit of $900,000. So I multiply the probability of succeeding by the net profit I'm going to make. Now, plus, I also take the other side because I'm looking at both sides. What's the probability of failing? The probability of failing here is 0.5. So I have the probability of failing 0.5 times, if I fail, what do I lose? I'm going to lose 100. That is why the negative sign is coming, because you're losing it. It's going to be, it's not a something gain. You lose $100,000. So that is why I said I multiply by minus $100,000. And if you compute this, you're going to have $400,000. And then I asked you to use the same approach to figure out how we got $310,000. And some people tried giving some of the data, but again, something was missing. Either something was more or something was less, and you know. We know it again. Something is wrong. Something is wrong. Try again. Let's see. Svit. Yeah, Svit, I think you got it. Yeah, I think Svit got it, but it's good to always put it in a beautiful way, Svit. That's going to be a little bit confusing. Oh, Prava, you didn't get it right. Try again, Prava. The way I think Svit did it is good, but the separation, something's missing. Okay, that's it. Perfect. Francis, you got it now. It's the same as what Svit gave, but it's just that you try to put it. Now you see, if you compute it, you're going to have 310,000. I don't know if everybody got it. This is, yeah, that's very good, George. You also got it. The bracket's important because when you separate it, you have the answer easily. The calculator can understand what it is you're doing. And I think I don't know. I thought I could put a calculator on the screen, but I don't know how to bring that on the screen. So forgive me, my IT is not very good. So okay, let's see what you're supposed to write. Here is very simple. Let me do it here. We said how to get this expected value, $310,000. So we said we start with the probability of success, which is 0.8. We said 0.8. That's the probability of succeeding. And if we succeed, we're going to make $390,000. So we multiply by 390,000. Now we close that. Now we add it to the probability of failing. If we fail, what's the probability of failing? The probability of failing is 0.2. And if we fail, we're going to lose $10,000. So we multiply by minus 10. I think this is where there's a bit of problem with some people. The minus sign, how it's coming in. Now there is a minus here. Okay, that's perfect. If you do that, you're going to get $310,000. So I don't know if this is a bit confusing or if it's okay. Is it very confusing? Yeah, I know the first try is always a little bit like that, but as we move on, it's very interesting. When we move on, you're going to see that it's really, really very interesting. Okay, so that's it. Now let's move on. Now let's look at the Xanadu traders. Xanadu traders, another situation. Let's look at it. We conclude this section by analyzing a decision involving international commerce. Wow. You see, this is very good. This example will be extended in the remainder of this chapter. So you take this Xanadu trader, anyways, traders. After this, I'm going to give you a copy of these notes. So if you're worried about having a copy of all of this, I'm going to give it to you. I don't want to give it to you now because there are some questions I'm asking. So if I give it to you, you see the answer, so it's not going to serve the purpose. So that is why I'm keeping it to myself first. And then when we are done, I'm going to make copies. I'm going to ask the coordinator to send a copy to everybody. So don't worry about it, but try to understand more as much as possible, and then you can take down notes and do some exercises. That's important. Now let's look at Zenado Traders. Zenado Traders, a privately held U.S. metal broker, has acquired an option. Now this is an option. It's important you start taking note from here. An option to purchase 1 million kilograms of partially refined molybdenum ore. That is a raw form of a kind of a metal that is used in producing lots of things in the computer, lots of different parts and stuff like that. So again, this is where it becomes very interesting, because we're going to have a lot of debate here to decide whether or not we can go on with this particular purchase. So they have acquired an option. They have an option to purchase 1 million. So let me underline that. It's important. They have to purchase 1 million kilograms of partially refined molybdenum ore from the Zerdavian government. Zerdavian government, I don't know, maybe somewhere in South America, for $5 per kilogram. So people should put down those facts. Total number of ore is 1 million kilograms. And how much per kilogram? $5 per kilogram, beg your pardon. $5 per kilogram. Now, molybdenum can be processed into several different products which are used in semiconductor manufacturing. And George Zenado, the owner of Zenado Traders, estimates that he would be able to sell the ore for $8 per kilogram. Again, he's going to buy for $5 per kilogram, and then he estimates, again, he thinks in the future, after purchasing it, he's going to sell 1 kilogram for $8. So how much is he going to make as net profit? Yeah, that's 3 million. Good. This guy, he got this one very smart. Well, so if he sells for $8, he's going to make 3 million. Now, after importing it, so he's going to sell it $8 per kg after importing it. However, the U.S. government is currently negotiating with Zerdavian over alleged dumping. Dumping is a crime. You dump waste material. Dumping of certain manufactured goods which that country exports to the United States. So they believe that they are dumping their waste materials through some of the products which they're exporting to the United States. As part of these negotiations, the United States government has threatened to ban, again, this is important in this case, they are threatening to ban the import from Zerdavia of a class of materials that include molybdenum. Again, that is the problem. They are trying to ban a group of products, including molybdenum. If the U.S. government refuses to issue an import license, if the U.S. government refuses to import an import license for the molybdenum after Zenado has purchased it, then Zenado will have to pay a penalty of $1 per kilogram to the Zerdavian government to annul the purchase of the molybdenum. Do you understand what's happening? So if the contract fails, for example, if the U.S. government doesn't issue the permit, the import permit license for molybdenum, it means Zenado stands a chance of losing how much? $1 million, because they're going to pay, good, they're going to pay $1 per kg just to cancel that particular transaction, that purchase. To cancel it, you have to pay $1 per kilogram. Now, Xanadu has used the service of Daniel A. Analyst. He's an analyst, a decision analyst, to help in making decisions in this type in the past anyway. And George Xanadu calls on him to assist with this analysis. From prior analysis, George Xanadu is well versed in decision analysis terminology, and he is able to use decision analysis terms in his discussions with the analysts. Now, this is the question. It's important because this is where we're going to do some work. Again, I hope you're taking down the facts. The analyst asked a question. As I understand it, you can buy the 1 million kilogram of molybdenum ore for $5 per kg and sell it for $8 per kilogram, which gives a net profit of 8 minus 5 times the number of kg, 1 million kg, that's 3 million, which you very well said. That's very good. I appreciate it. Now, however, there is some chance that you cannot obtain the import license, in which case you will have to pay $1 per kg to annul the purchase contract. In that case, you will have to actually take the molybdenum and pay Zedavia for it. You won't take it anyway. You don't take it, but you still pay for it. And that makes you lose $1 times the 1 million kg, which is $1 million. That's very good. You also have that correct. To the cost of annulling the contract. Now, Xanadu says, actually, some chance. Again, take down the facts. Actually, some chance may be an understatement. The internal politics of Zaldivia make it hard for the government to agree to stop selling their manufactured goods at any low prices here in the United States. The chances are only 50-50. Again, what's the probability? %. Or zero, good, 1/2. That's good probability. The probability is 0.5 of positive 0.5, negative 0.5. So it's a 50-50 probability. You're going to need this information as well. So where was I? Okay. So the chances are only 50-50 that I will be able to obtain an import license. It means if he obtains an import license, there's 50%, the probability is 0.5. And then he stands the chance to make a profit of $3 million. If he doesn't obtain the license, he stands to lose how much? $1 million. Perfect. You got it. So as you know, Xanadu Traders is not a very big, large company. So the $1 million loss would be serious, although certainly not fatal. On the other hand, making $3 million helps balance the sheets. Okay. Now let me ask you, would you go for it before we go to the next part of it? So which alternative should Xanadu select? Assume that Xanadu uses expected value as his decision criterion. Now, so you're going to use the expected value as the decision criterion to help you make your decision. Again, let me go back and remind you of the expected value. Here you look at the expected value is $400,000 and the expected value here is $310,000. So if we're using expected value as a decision criteria, then we choose to make temperature sensor because the expected value is more and this is less, so we're not going for a pressure sensor. So it's the same. You draw your tree, come up with your decision tree, and let's see what you got. Please, everybody can try it, and I don't know if I should leave it as, no, let's do it in class. Let's try it. Just take a piece of paper and a pen. You have about 5 minutes. Draw your decision tree, and then let's share the information on the board. Everybody's going to give us the expected value. Well, I already have an expected value. So this is the expected value is 1 million. Okay? Let's see what the others are going to have. Wow, that was very fast, you know. So, Suvit, this 1 million expected value, I like to see the mathematics. You know, we're talking about how you put the figures, and you put that in the figures, like in parentheses. You put how you did the multiplication. We're interested in seeing how you carry out the arithmetic to have 1 million. So you can just add that as well, so everybody can understand. Okay, so Suvit, you said 300,000. Where did you get 300,000? Okay, George, but you didn't give an answer, George. You showed some work in there, but you didn't give an answer. So what's your expected value? 1 million. Okay. So you're confirming with Suvit. Okay. Anyone else have something different? Is they said 50-50. The chances, Amen, is it Amen? Yeah. Amen, they said the chances are 50-50. So 50-50 means 0.5, or 1 half, and 1 half, and 50% and 50%. Okay. Yeah, it's like Samuel is also having the same thing. 1 million. Okay. Okay, then let's take a look at it down and see whether we had it right. Now, so to answer this question, construct a decision tree. I don't know if you did. I asked you to do that. Now, there are 2 possible alternatives. Purchase the molybdenum or don't purchase it. These are the 2 possibilities. So, did you have these 2 possibilities? So, your decision tree has 2 arms. That's very good, Suvit. It has 2 arms. You purchase it, the same for Samuel and those who did it. That's good. So, you either purchase it or you don't purchase it. Now, that's fine. If the molybdenum is purchased, then there is uncertainty about whether the import license will be issued or not. So that is where we have a problem. But again, the decision tree in figure 1.5, which is down, Let me just go to that tree so we can. This is at 1.5. Now, I hope you had this same decision tree. Now, this is where we start. We purchase it or we don't purchase it. Now, if we purchase it, now, there are two possibilities. There's a 50-50 chance that the license will be issued or not. Now, if the license is issued, and then we're going to sell total of 8 million. Do you know how we got 8 million? So this is just $8. $8 is per kg, right? Good. And then the net profit will be 3 million, which we all got correct. Now, if the net, the import license is not issued, which is also a 50% probability, beg your pardon, that is not going to be issued. And then we're going to lose $1 million. That we will lose $1 per kg, because we're going to pay $1 per kg. Now, so let's go back. So the expected value is $1. Now, you used million because you placed the millions, and which is still very correct. So I'm not saying it's not correct. It's still very correct. Now, because here we used only 8, because we said we're going to sell at $8 per kg. And if we sell at $8 per kg and we bought at $5 per kg, 8 minus 5 is $3. So per kg, we're going to make a profit of $3 per kg. And if we do not get the license, what happens? It means we're losing. So it's $4 because we're paying $1 for every kg. So it's going to be $4 minus 5, so we're losing $1 per kg. Now if you multiply now by the number of kgs and whatever, which you did very well. So will you go in for this decision? Would you make this take the decision to buy the molybdenum? How many people would buy? Well, everybody's going to buy. Okay, so that's fine. So you see, making decisions with a decision tree is very exciting, isn't it? It's very easy to do. It's not complicated. You just need to get the information. I know the problem with many people using a decision tree is the information gathering. So this is the literature of the same tree which we just talked about. And it's very easy. So again, I'm going to go back. To get the expected value, we add the two probabilities. We add the two probabilities with their net profits, multiplied by their net profits, so to get the expected value. That's any question at this point, so I know how we're making progress, whether it's okay or it's not okay. If there is any questions, let's try to solve. Okay, that's okay. So I hope the probability tree issue is interesting. Okay, now that's fine. So dependent uncertainties. Now again, the first part was very easy. Now we're moving on to a different part. It's going to look a little bit, here and there. But again, it's still the same. You just have to be smart on getting the data, and then from the data, it's going to be very easy. Now, before we go to this dependent uncertainty, I wanted to just take a look at, explain a couple of things before we move on. Now, when we're talking about probability, we said probability is the likelihood of something happening. We don't know if it's going to happen, but again, let's say we have a fair coin. We know what is a fair coin, right? It's a coin. Of course, it has two faces. Let me draw this as a fair coin. This is our fair coin. And let's say this is the head. I don't draw very well. Let's say this is the head. And then the other side is the tail. So if this is a fair coin, if you flip the coin, you can have either a head or a tail. Now, how do we calculate probability? This is very, very easy. Now, what are the number of outcomes we have? The possible total number of outcomes. How many possible outcomes do we have if we flip this coin? 2, only 2, that's it. So the total number of outcomes, we call it a sample space. This is very important. Now we call it a sample space. So we have 2 total number of outcomes. Now, each time we flip the coin, how many total kind of results can we have? Only 1, perfect. So we can have 1 result, either a head or a tail, divided by the total number of outcomes. So the probability of having a head or a tail is 1 divided by 2, which is very easy. Now let's take a box. This is a die. Again, this is a fair die. I'm going to connect the edges. I hope this one looks good. Okay, this die, you have maybe different points. You can have a 1 here, you can have a 2 here, you can have a 3, I don't know, and so on. Now, how many total number of outcomes can we have on a 6-sided die? Oh, I see 1, 6, 6, 6, 6. Yeah, because there are 6 sides, so the total number of outcome is 6. We cannot have more than 6 because we only have 6 faces. So if you throw the die, you can only have 6. Now, each time we throw the die, what is the number of outcomes that we can have? We can only have 1. That's it. So the probability of having maybe a 1 or a 2 or a 5 is only 1 divided by the total number of probability. That's called a sample space. Now this is very easy. Now the question I'm going to ask you is, what is the probability that if you roll this die, you can have either a 3 or a 5? Now we're looking at just 1, right? Now, it's 2 on 6. So let's say 2 on 6. Any other person has another answer? If we roll the die, we can, good. Because that's perfect. Because we have 2 results. Yeah, which is 1/3. That's correct, George. That's a more simplified form. It's 1/3. So if you roll the die, you can have, for you to have either a 2 or a 6 or a 5, there are 2 of them, 2 possibilities, either a 2 or a 5. So it's 2 over 6, the total number of outcomes. Now, we're going to look at another one, but we don't have a lot of time. This now, you see, I'm moving from simple to complex. Now we are going to look at the probability of picking some balls in a bag. Say there is a bag, and then there are some red balls or yellow balls and green balls in it. What's the probability of picking maybe a blue ball or maybe a red ball? We're going to look at that in the next class. So I hope it's an interesting topic. Again, I'm going to relate it to business. We're not just looking at it. We're looking at these mathematics and then relating it to business. So you see how it's practical. Thank you very, very much. And I hope it's interesting. And I'll try to maintain it to be very interesting. And it's going to help us in decision making and stuff like that. Okay, thanks. Maybe when I go now, I have to have some discussion with my wife and see my baby and again, and that's good. Okay, I wish you all the best. Have a great evening. Okay.